Alright, so for us to make sense of our definitions and what we're going to talk about today, I think this is a great place for us to get started. So again, is 5 a solution to the equation negative 14 equals 3x minus 1? Now, again, I'm not asking you to solve this. Okay? In fact, I don't want you to solve it. I want you to be able to answer this question without solving it. So who can remember, this is actually all the way back from section 2.4, when we first started solving equations. Delaney, what do we do to determine if 5 is a solution?
You put it in the empty spot.
Alright, you're going to take the value of the, or you're going to take the variable, you're going to get rid of it, and you're going to replace it with the number that you want to check. So what this would look like is this. We would take negative 14 is equal to 3 times x now is going to become 3 times 5, and then we're going to subtract 1 from that. And all we're going to do is we're going to simplify the left and the right side until we determine whether or not this is a solution. Well, the left-hand side, I'm going to be honest, is already simplified. It's always going to be negative 14. On this side, we're going to follow the order of operations. We're going to take 3 times 5, which is 15, and then we're going to take 15 and we're going to subtract 1, which means that we're left with this statement. 14 equals negative 14. So what did this tell us when we were done, Delaney?
It told us that it equals 14, not negative.
Okay, so what's that mean? Well, answer the question for us, though. What does that tell us for the question?
Oh, no, it's not.
All right, we are able to state that 5 is not a solution. All right, remember, when you are testing if a number is a solution, okay, this is what we've been doing for a long time. We've been checking our answers. It means that if you replace the variable with the number, that the left side and the right side turn out to be equal to one another. We did this yesterday when we checked our answers. We plugged a number in on the left-hand side, we plugged a number in on the right-hand side, and we evaluated each of them, and we found out that they were always the same number. They were equal. Okay? So, what does this have to do with anything else? Well, like I said, I don't think your definitions are going to mean anything unless you keep in mind, what does it mean to be a solution? Okay, in order to be a solution, it tells us that when you replace the number or variable with the number, you are getting a statement that ends up being true. Okay? Now, I've been talking about this for the last couple of days, and I alluded to it during third period. We're going to see 2 special cases today. And we have to be good at solving, because you're not going to know until the answer is done what case you have. Okay? So, let's begin with our 2 definitions and then talk a little bit about, like, when do these arise, what do they look like, how do I know which one is which? Okay? So, we're going to begin with our definition of what is no solution. Alright, here's what we're going to say. Any equation has no solution if there is no number that makes the statement true. And when I say statement, I'm talking about an equation or an inequality. I specifically did not put makes, or no number that makes. I didn't say the equation true because I want to expand on this in our next unit. So an equation has no solution if there is no number that makes the statement true. Again, you might say, what statement are we talking about? We're talking about this statement right here. This is a statement. I want to know, when does negative 14 equal 3x minus 1? There are times, ladies and gentlemen, where you cannot find a number that makes the 2 sides equal to one another. Okay? Now, how does that show itself in our work? That's what I'll explain here in a couple minutes. But I'm just going to real quickly just kind of give you an example. If I were to tell you that 3x is equal to 3x plus 5, I'm going to tell you right now, there is no number known in this universe that if you plug it in, the left side and the right side will ever be equal to one another. Ever. It will never happen. This is a perfect example of the left side and the right side never being equal to one another. Okay? This is going to be an example that has no solution. And you might say, what do you mean no number? Literally no number ever. Like if you plugged in 0, what would this side become? 0. What would this side become? 5. If you plugged in 1, this side is 3. This side would become 8. If you plugged in 2, this side is going to be 6. This side is 11. If you plugged in 3, this side is 9. This side is 14. And you might say, well, but Mr. Tompkins, you haven't picked many numbers. Yes, I realize that. But we could sit here for the rest of our lives finding a number and find out that they're never going to be equal to one another. Okay? So, we will come across equations that have no solution. Now, on the opposite side of that, we will have equations that have many solutions. In fact, they have an infinite number of solutions. Okay? And here's what we know by that. This is what we call an identity. This says this, an equation is an identity if all numbers make the statement true. Equation is an identity if all numbers will make the equation true. Alright, I'll give you a quick example here. If I were to give you on one side the equation 2x plus 4, and on the other side I gave you this equation here. Okay? I'm just going to show this real quickly because I'm going to show you that it works for more than one, which automatically is going to be different than everything we've done before. Alright? Quentin, give me any number you want. Make it something I can do in my head though, please.
1.
Okay, 1. Let's plug 1 in here. 2 times 1 plus 4 equals 2 times 2 plus 1. Okay? If I work through the left-hand side, we're going to begin by multiplying first and then adding. So 2 times 1 is 2, and 2 plus 4 is 6. Okay, on this side, we're going to do order operations, which says we're going to start inside the grouping symbols first. Okay, this is going to become 2 times 2 plus 1 is 3, and 2 times 3 is 6. So does everybody see that when Quentin plugged in 1, we got the same answer on both sides? So that means 1 is a solution, because when I plugged it in, it made both sides equal to one another. Okay? All right. Bryce, give me another number. That, again, is going to be somewhat easy to plug in for me.
Another number?
Yep. Anything other than 1?
2.
2. 2 times 2 plus 4 equals 2 times, and then in parentheses, 2 plus 2. Okay, again, if I follow the same rules, multiply first, add second, 4 plus 4 becomes 8. Over here, we would add first because it's inside parentheses, and 2 plus 2 is 4, and 2 times 4 is 8. So notice that Quentin gave me a number that when I plugged it in made it true. When Bryce gave me a number, it also made it true. If I ask Emma for a number, it's going to make the statement true as well. Okay, what if I plug 10 in? Well, this side would be 2 times 10, which is 20, and 20 plus 4 would be 24. Over here, what's 12 plus 10? 2 plus 10? 12. What's 12 times 2?
24.
I'd get the same thing, wouldn't I? I'd get 24 equals 24. So the complete opposite of this over here, where I tried to plug in numbers and I never got the two sides to be equal, over here, when I plug in numbers, I'll never get them to not be equal. It is the complete opposite. Okay? So here's what we need to keep in mind. When we solve equations, and this will happen tonight on your homework, there are 3 scenarios that are going to turn up. You need to know when in your work what these are going to look like. So before we start solving any equations here, okay, I want to try to summarize it. You can throw this on the back if you've got room, or on the bottom, or wherever, but I'm going to try to summarize our 3 cases. All right? First of all, we have the one that we haven't thought much about because we've just been solving and solving and solving. What if I have one solution? Now, I'm going to show you an example of what the last line of work looks like. Okay? One solution is every problem that you have solved up until today. Okay? And when you are done solving an equation prior to today, you got answers like x equals 5. When you have the variable left in your problem, this is what I'm going to tell you. When you have a variable left in the problem, you are guaranteeing that there is one solution to that problem. Okay, whether that variable is x or y or m or b, if it is left in the problem, it is guaranteed to be one solution. Okay? An example of an equation that has no solution. What will happen in a no solution, and you'll see here in a few minutes as we do examples, when you get all of your variables on one side, they're going to cancel each other out. 100%, and you're going to lose all of your variables. And what you're going to be left with when you do that is an example like this. 13 equals 6. You might say, well, that doesn't make any sense. 13 can't equal 6. Exactly. That's why it will be determined to be a no solution problem. Notice it doesn't say x equals 13 or x equals 6 or 13x. There is no variable left in the entire problem. When this happens, we will automatically put that there is no solution. Okay? Identity. Now, identity, I'm also going to talk about this because sometimes we think identity is an actual word that means something special. Like, it does. What's it mean? It means all real numbers. It means that you can plug any number in and it's going to make the left side and the right side equal to one another. Okay? Wow, let me jot this stuff down. Okay, what's going to happen when I have an identity? Well, just like in the no solution, when I get all of my variables onto one side, they're going to be canceled out. But here's what's going to be different. I'm going to be left with something like -3 equals -3. What's the difference here? Well, this statement here isn't true. This statement here is. That's literally the only difference. Both of these will have the variables gone from the problem. The difference will be I'm either going to have a statement that is true when I'm done, because -3 does equal -3, or I'm going to have a statement that's not true, like 13 equals 6. So, knowing this, we need to keep this in mind, because again, tonight, on your homework, we've mixed them all in. It's not going to be like, hey, today we're just practicing one answer, tomorrow infinite number, and the next day no solution. No, at some point, these are all got to be within the same set of problems. Okay? So, please be aware of that. Alright, now, yesterday, if I remember correctly, we did the first 4 in example number 1, right? We are down to example 1E. Now, remember, we have our steps that we are talking about when it comes to solving equations. So if you need to keep those out, you should probably keep those out. Okay? So steps for solving an equation. So, what's the first step that we should always try to do? Simplify each side of the equation. Okay? Can I simplify either side of the equation in example 1e?
Yes.
Yes. Okay, what is simplify telling us on the left-hand side? We're going to distribute. Alright, so if we distribute, 3 times 2x is going to give us what? 6x. Plus 3 times 1, which is going to give us 3. Equals, and the other side is just going to be 6x. Now, there's a reason, again, we've talked about it. I like the next idea of, well, first of all, sorry, can we do any more simplifying? No. Okay? So, the next thing that I would do is I'm not going to worry about moving the 3, but I am instead am going to gather together my variables. Okay? Now, let's think a little bit ahead. Which side would make the most sense for me to get my variables on? The left or the right?
Right.
The right. Because my numbers, my constants, are already on the left. So if I want to move this 6x over to here, what do I need to do? We need to subtract it. So we're going to subtract 6x here, we're going to subtract 6x here. Now, here's what always baffles me. Always baffles me. Don't write this down, but this is what I'm going to see a lot of you do. 3 equals x, and you're going to move on and be done. No. Okay? A lot of people do that, though. Here's my question. What is 6x minus 6x? 0. Okay, so the only thing I have left over here is what? 3. So what's the other side? 0. It should be 0. If 6x minus 6x is 0, then on this side, 6x minus 6x had better be 0. So, we got to put a 0 there. Not a 0x, nothing else. We literally just put 0. Okay? Now, what do we notice? My variable is gone. It's been eliminated. That's okay, because that's now going to happen. What that tells me is this does not have one solution anymore. It is one of these two cases here. Okay? In Delaney, it is a what?
No solution.
And why do you know it's a no solution?
Because they're not the same number.
Because the statement that I have here isn't true. 3 doesn't equal 0. Never will it equal 0. So if the statement that I have left is not true, then I need to put no solution. And that's the answer to that problem. When you take your assessment on Friday, if the answer is no solution, then you're going to need to be able to write no solution as that final answer. Okay? Now, let's take a look at letter F. So, step number 1, we would again look to simplify. Can we simplify?
Yes.
Yeah, we can simplify on both sides. So we're going to begin by distributing through my positive 3 on the left. So 3 times 2a is going to be 6a, plus 3 times 4, which is going to give us 12. Okay, on the other side, we're going to distribute through a positive 2. 2 times 3a is 6a, plus 2 times 6 is 12. Now, can I simplify the left-hand side anymore? No. Can I simplify the right-hand side anymore? No. So then the next step that we're going to do is we're going to get all the variables on one side. Okay? Miles, how do you want to do that?
Subtract 6a.
All right, let's go ahead and subtract 6a here, which means we're going to subtract 6a here. So 6a minus 6a is what? 0. So what do I have on the left-hand side?
12.
I just have 12. On the other side, what's 6a minus 6a? 0. So what's the only thing I have on the other side?
12.
I also have 12. Again, here's what I know. This does not have one solution, because I do not have a variable left over. So, I either have to put no solution or identity. This is a case of an identity, because Over here, the statement I was left with is not true. Over here, the statement I'm left with is true. So, as a result, we are going to put the phrase identity. Now, I'm not going to be super picky. I use these interchangeably because they mean the same thing. Our definition of an identity said it was an equation in which all numbers made it true. I'm fine if we put identity, and I'm fine if we put all real numbers. I will tell you this, your Algebra 1 teacher, whether it's myself or someone else, will expect you when you walk into Algebra 1 next year to know that those mean the same thing. All real numbers and identity mean the same thing. Alright, now, I'd like you to flip it over and I'd like you to work out just the next example, please. On the back. Alright, so let's start with this. Can we simplify either side of the equation?
Yeah.
Yes, we can. We have like terms over here. Negative 15c plus 7c is what? Negative 8c plus 1 equals 3 minus 8c. Okay, can we simplify either side of the equation anymore? No. So our next step should be to get all the variables onto one side. So, let's see. Roland, what do we want to do?
Subtract 8.
Well, but this is already a negative 8. Both of them are.
Well, add 8.
We need to add 8, okay? So let's add 8 to this side here, or 8c, and then add 8c here. So on this side, when we have negative 8c plus 8c, we get 0. So what's left on this side over here? 1. 16. Okay? On the other side, we still have our 3 that we'll bring down. What is negative 8c plus 8c? 0 again. So what's happened? The variables have been eliminated. Because the variables have been eliminated, I need to put one of these two answers. Which one is this?
No solution.
It's a no solution. Because the statement that I have is not true. 1 does not equal 3. Alright. Now, try example H. subtract 15, or you could subtract 12, because you can remove either side. But I would get all variables together first. Yep. Nope. You distribute, so 15b plus 3 times 4 would be 12. I've seen 2 correct answers. 2. This is what I'm talking about. On your homework tonight, you got to be able to distinguish what is what. Alright, now let's walk through this one. I am just mean enough to do this to you. Because a lot of people automatically will be, hey, well, this is going to be an identity because we've had 2 no solutions. We need 1 more identity to match them out. I'm not worried about making things equal. I'm worried about whether or not you can solve an equation. So, let's walk through this one. Can I simplify the left-hand side? Yes. What do I have to do first? I've got to distribute. 3 times 5b is going to be 15b, plus 3 times 4 is 12, minus 36 equals, can I simplify the right-hand side? Yep, we're going to distribute. 6 times 2b is 12b, minus 6 times 4, which is 24. Alright, I got to ask, are we done simplifying? Nope, we still got to keep going. On the left-hand side, that means these 2 constants need to be combined together. So I still have my 15b over here. What's 12 minus 36? So minus 24 equals 12b minus 24. Now, can I do any more simplifying? No. Alright, so this is why I think this next step is a big one. What should we work on doing? Getting your variables together. Kane, how do you want to get your variables together?
Subtract 15 on this side.
Alright, Kane wants to subtract 15b here and subtract 15b here. So what's 15b minus 15b? 0. So what do I have on that left-hand side still? A negative 24. What is 12b minus 15b? Negative 3b minus 24. Here's what I can tell you right now. This is going to have 1 solution. How do I know it's got 1 solution? Because I still have a variable in the problem, don't I? And if I have a variable in the problem, I am guaranteeing you that I have 1 solution. We have to find it. You're left with a 2-step equation to solve. What's the next thing we're going to do here? We're going, not divide yet. We got to add 24 here. So we're going to add 24 here and add 24 here. What is negative 24 plus 24? 0. On the other side I have negative 3b, and then my negative 24 and 24 still give me 0, right? Now a lot of us were like, okay, I'm done. No, you're not. You haven't solved for b yet, ladies and gentlemen. What do you still need to do? You got to divide by what? Divide by negative 3. What's 0 divided by negative 3? 0. What's negative 3 divided by negative 3?
Negative
1. 1. So I have 1b. There's my answer. Now you might say, well, but how can b equal 0? Because b is 0. It's the value that if you plug it into the left side and the right side, it's the one value of b that's going to make the 2 sides of the equation true. That's what you're looking for. So here is why I am such a big proponent of those steps. After I've simplified, when I get all of my variables on one side, whichever side it goes to, as soon as I've done that, I should be able to tell you, are we having one solution, or are we having no solution or an identity? If I have no solution or identity, I'm done. I can just tell you that right there. But if I still have a variable left, ladies and gentlemen, you have one solution. You better work your way through and solve it. Okay? Now, here's the last thing. Sometimes people will get really good at solving, and they always think then, Mrs. McClure and I always pull our hair out every year this happens. I'm lucky mine grows back in time. Okay? But I'll get students that'll tell me, hey, Mr. Tompkins, x is 3, but there's no solution. How can that be? How can x equal 3 and there's no solution? Or they'll tell me that x equals -7, but it's an identity. That doesn't make any sense either. You only put identity if the entire answer is an identity. If x equals 3, guess what, ladies and gentlemen? It's not an identity. If x equals 3, it's not a no solution. It's a one solution, and it's telling you that that's the solution. X is equal to 3. Okay?
So I'm gonna compare it to when you guys did substitution, and like at the beginning when he said, is this number a solution? Was it 5?
Yep.
And, at the end, you had to say 5 is a solution or 5 is not a solution. You have to have a word ending. This is not that. You only write words if the variable goes away.
Absolutely. All right, your assignment for tonight is page 133, numbers 10, which is a story problem. We didn't do any of those last night, and 15 through 26. I'm going to tell you the same thing I told my algebra class yesterday, because they found out today when they had to take their test. I'm not worried how many of these that you get right tonight. I'm worried more than anything else that these get done. And I don't always say that. You're going to miss several tonight. I can almost guarantee that. But you need to have at least made an attempt, so when we go over this tomorrow, you can be like, okay, now I know why I missed it. Not one of those, oh, it looks like I understand it because I follow what Mr. Tompkins did. That's not what I'm looking for. You need to make sense of why you missed what you missed.